Thanks a lot. It somewhat follows on from what Enrico was just talking about, and it pertains to credibility, the credibility of egress models, specifically in this case the subject matter that we're addressing. And not wishing to misquote Isaac Newton or develop that, but it's actually worse than what Isaac Newton says, because humans also use the models and then make use of the results. So there's no aspect of what we do that hasn't got a human element. So it's that the madness continues beyond just those of us that look at egress models. This diagram here, I think, sums up quite a lot about what my speech is about today, my presentation. This was a diagram produced by Canterbury and Syme regarding domestic behaviour. So how evacuees made their decisions during an evacuation from their home, and these represent the specific actions or stages of those actions. And just look how complicated it is. Now, the reason that's useful is because if you think of how complicated that is and how simple our egress models are, we need to recognise how much of a journey we take from that to the results that we use to inform our designs. And just bear that in mind as I go forward, because my hypothesis, I guess, is we don't understand much about this, but we include even less in our analysis. And there's value in knowing how far away from the real picture we are. Not just there's value in including it, but there's value in knowing how far away we are. Okay, now how do I get it such that this moves? Okay. So what am I going to talk about today? I'm going to give just a brief overview now I'm going to just go through some of the subject matter that I'm talking about, and that is evacuation behaviour. And then what we did as part of this work was to provide a set of core behavioural statements. These were things that were discussed in the field related to how people behaved or how they made a decision during an evacuation. Then I'm going to go into how these behavioural statements might have an effect on model development and model application, and finally, and probably more importantly, on procedural design. So how these things actually have an effect on the real environment and how we address real incidents. I'd like to acknowledge Erica Kuligowski at NIST, Lynn Hulse and Mike Kinsey. Lynn's at University of Greenwich and Mike's at OVARUP. We've got 2 articles coming out that address this, and so this is like a bit of an insight into what they'll be addressing. Okay, so human behaviour in fire as a topic emerged from practice, and I think we should bear that in mind, because there was a need driven by engineers in the field, practitioners in the field, and then we somewhat caught up with this, the need to support and inform engineering practice rather than it coming from theory. And this was initially, I think, came from the 60s, 70s, John Bryan, Jonathan Syme, Peter Wood and so on, Ghislaine Proulx later on. But the field is still relatively immature to the extent that it doesn't have a clearly defined name. So think of it as an unnamed, slightly adolescent, oversized child. But because of this, traditionally evacuee performance was either ignored, factored out, included in some sort of safety margin, represented implicitly, or was deemed, as Enrico mentioned, beyond consideration. Even if that was the case, it's still quite a dangerous assumption to make. Now, it has become more accepted, but there's still a great deal of effort required to develop the theoretical and empirical credentials of the field, such that acceptance is more widespread and that practice is more consistent and more authoritative. Now, to do this, what I'm trying to talk about today is to enhance the acceptance of the subject matter that's being addressed and the subsequent modelling of that subject matter, and develop what I call a sceptical advocacy. So I'm very much an advocate of representing human performance and then quantifying that performance, having this evidence-based approach. But we have to recognise where we are in the journey of doing this to a very accurate or credible way. Now, this becomes all the more important given the changes in our regulatory environments, the fact that we actually require some of these models now. And as codes develop still further, move from prescriptive to objective to performance-based designs, we're going to really need to have a credible, quantifiable measure of human performance such that we can directly inform design. And also support For instance, the changes of prescriptive codes, which I'll get onto later. Okay. Here's the issue though, we don't really have an overarching theory within our field that describes human performance. And this is a real problem because what happens is the media plugs the gap. Now think of it like this. Most people have an understanding of how people behave in a certain situation because they are the subject matter. We have some people in here are experts in human behaviour, some are experts in other aspects of fire safety. But we all have an opinion as to how people behave in a fire. I have absolutely no opinion about pyrolysis. Most people don't, but everyone has an opinion on how we behave because we are the subject matter. That's our problem. You can be an engineer in the field, have no specific expertise, and yet have an opinion on how people behave in fire. I have not the first clue about pyrolysis. I had to look up the meaning. But that's our problem, and the media fills that gap. I noticed today, scanned through the BBC, there were two news stories. The British economy is in panic because of the potential Scottish independence, and the British public were in panic because Prince William and Kate are pregnant again. So these are two different definitions of the term panic in one day's news cycle. But that aspect, that assumption, still infuses a lot of discussion and analysis. Now, the fact that we don't have an overarching theory and the fact that there's not too much acceptance on the things we're talking about, the key areas of the subject matter, means that there's variability in the assumptions made by practitioners, by model developers, model users and regulators. And this affects both how we develop, use these models and how we interpret the results. So, and this again comes from this hangover of the fact that the area was driven originally by practice rather than theory, but currently theory and data is not sufficient in scope and content. We have to recognise that. It's not universally accepted or applied. Even some of the good data and the good theory that's available isn't always applied. Our theories, or as I call them, our sort of behavioural statements, aren't equivalently tested or constructed to the same degree of rigour. And they're not described consistently and simply or equally accessible. And those two things are what I'm sort of looking at today. So this brief presentation today is sort of trying to address those two last points. And what we did was scan the material that was available, the literature, and try to come up with a core set of statements that people used in the field to describe how people behave. So this was almost like our core set of subject matter factors that we have been used typically by more than one group of people. These were derived from observations, research and practice. Now, understanding these core set, and by the way, this is not an exhaustive list. There were certainly others available. These are our sort of top 24, I think, that we came up with. We felt that this was critical to have an awareness of this subject matter in order to then go and model it. That's not to say that all of these can be represented at the moment, but that awareness of this is what's actually deemed to occur is valuable, because you can at least say what's in and out of your model at any stage. What's actually being represented, what's being excluded and why. So hopefully that aids in the transparency of the process. This was a conceptual model that Erica was working on, Erica Kulgowski, specific to the World Trade Center and the pre-evacuation period. So conceptual models are appearing, but they are typically focused on an event or some aspect of an event. So what we need really is a framework, a structure that we can sort of hang all these subject matter factors on. Now I thought it would be instructive as well just to talk about what we're talking about here in terms of a model. What models could benefit from this type of understanding? Well, the top left there is sort of a standard egress model, the Simulex model. I've just picked it, could have picked one of 65 or whatever they are. But that has an embedded conceptual behaviour model in it. It makes some assumptions and it includes some behaviours. The calculations in the SFP handbook, that has a behaviour model embedded in it. It makes, in this case, and I've now taken over this chapter, but in this case it makes an assumption that movement speed is directly related to density, population density. Now I'm not saying that that's right or wrong, I'm saying that's the assumption that's made. And it makes that assumption over and above many other assumptions that you could equally make. The bottom left-hand picture here is an evacuation drill. A drill is a model of reality. It includes many factors and excludes others. And it depends on how you set it up, how you announce it, and so on. And of course, there are existing conceptual models that describe performance, and that's where the assumptions are more clearly stated. But also, and this is perhaps where these factors become more opaque and are sort of hidden, the evacuee themselves has an internal model that describes how they perform, and that affects their decision-making process. The supposed expert, and I apologise for the strange graphic there, I was trying to differentiate between an evacuee who was concerned and me who's slightly less concerned with a glass of wine. But you know, experts have supposedly an internal conceptual model of their expertise, their subject matter that they deem to be expert over. Firefighters have an internal model that they use to govern their decision-making process. That may be driven by doctrine, procedure, depending on their unit, and also on their ability to cope with the situation they're faced with. Also, the codes, the prescriptive codes, have a model built into them. They make an assumption, or many assumptions, and exclude others. One of the benefits we thought of putting these statements together was you could then more clearly see what's included and what's not included in each of these models. For instance, I've deliberately picked an old example here because it may have changed, but this looks at the maximum travel distance allowed in different occupancies. And so the behavioural assumption here is that these occupancies and the presence of a sprinkler are the key factors that should be considered when looking at required allowed travel distance. Now that makes an assumption that travel distance to some degree can be covered in the same manner. So what I'm now going to do is go back through a couple of examples, a couple of cases where we derived some key behaviours. So in this instance, this is the Summerland incident that was looked at by Jonathan Syme. This was like a Las Vegas style, or sort of a very lo-fi version of a Las Vegas adult theme park in the UK. 50 people died in this fire. What happened was a fire started. It was actually reported from outside outside of the building. It was never actually reported from inside. And fire quickly developed and information wasn't shared evenly throughout the building. But many of the adult population that were located in the building then moved towards their children who were located in a creche somewhere else within the building. So their response was to go and find their relatives, their young relatives. They didn't have any information about their condition. I think that by the time they got there, they'd been safe. They'd been evacuated to a safe location. But that created bi-direction on the stairs weren't protected, and so many people were exposed. But this highlights a few points. Firstly, your social identity matters. Who you were beforehand and your relationship with someone survives the incident. And also, people do not necessarily move directly to a place of safety during an emergency. Second incident. This was the Valley Parade incident, a soccer football stadium in the UK. It was the final game of the season. A fire started underneath the terrace. There you can see in the top left-hand corner, it's just starting to grows more severely, and then the entire side of the stadium was engulfed in very little time. Key issues here were people in the stadium didn't necessarily interpret the danger that they were faced with. Also, at this period in time in the UK, football violence was a big issue, and it was if a fan entered the pitch, they were banned for the season. So there was a social, cultural issue that stopped them necessarily evacuating to a safe place quickly. And so there was some reluctance of people to move onto the pitch anyway because of the social and cultural system that was there at the time. So again, this prompts a few issues regarding people's interpretation of queue isn't necessarily consistent, and the fact that the organisational structure in place does have an impact on the way that people evacuate. You can't just make assumptions regarding that. Now, the King's Cross fire in 1987 occurred in a London underground station, a metro. 31 people died. The fire started on an escalator. I think it was a discarded cigarette. The escalator caught fire, and a very severe fire then developed. Now, the response was reasonably confused given the severity of the incident, but also there was an interesting dynamic between the different types of staff that were present on the day. There were 2 off-duty police staff, actually I think they were in one of the lower levels, who then took local control of some of the evacuation and gave the passengers some information. At the same time, the rail staff both initially delayed and then provided conflicting information. Now, the way the public saw the police and how they saw the rail staff was totally different. The police were seen as people that normally dealt with emergencies, whereas the rail staff were actually held in slightly lower regard in that particular scenario. And so the way that the public responded to the information provided differed on the credibility of the source. Again, this incident prompts a number of interesting behavioural statements. The people respond to information available, the conflicting information can arise, and the authority of the source matters. It's not just that information exists around people, that the source of the information has a direct impact on the way that we perceive it. Okay, finally, this is the Beverly Hills Supper Club incident of 1977. 164 people died. The vast majority of these were in the cabaret room in the top right-hand corner here. A fire started in the zebra room, the bottom right-hand corner, and moved up the corridor here. Oh, I can't show you. Up the corridor and blocked that while people were still seated in the cabaret room. Now, the staff initially tried to address the fire and failed, and so the fire developed and eventually blocked the egress route out from the cabaret room down south to exit D, which was the main mode of entering the building. The people in the cabaret room, and I think there was like 1,500, 1,600 people in there, were unfamiliar with exits A and B, which were the only ways out of that room at that stage. Now, these exits were recessed and so weren't clearly visible. At that point, those people had no safe means of egress that they were aware of from the space. A busboy, Walter Bailey, jumped onto a table and separated the 2 groups of people and told them which exits to use. There was some reluctance to do so because this person was a busboy, not a figure of authority. But after a small period of time, they became aware of the 2 exits and then used them broadly as Walter Bailey indicated. There was insufficient time for them to get out by this stage, but many more people would have died had he not have done that. The point here being, even in this situation, the overriding behaviour wasn't competitive, irrational panic. We know this because Feinberg and Johnson did an analysis of this and looked at where people fell, where people died. The expectation would be, if it was subject to some sort of irrational, violent act of panic, that you'd get stronger, fitter people towards the exit and social groupings would separate. This just didn't happen, or certainly didn't dominate the response. It also indicates that staff actions can certainly have an impact, and again, access to information is critical. So what we did was we gathered our evidence and we categorised these statements into these different 5 phases. So there's an assumption there's external information available. This information are then processed, internalised. This information is then assessed given the information already available to the individual and an assessment of the risk produced. A response is then selected and an action taken. And of course the whole process in itself is often described in the material available. Now, importantly, what this also tells us, as well as what we might include in a model, is what egress scenario should we be looking at when we apply a model. And that's important when we recognise actually that there is a limit as to how sophisticated some of the models can actually get now, but that doesn't necessarily limit the egress scenarios that we can discuss and look at. So I'll just go through a couple of these. As we've already mentioned, the content of the queue matters. So the format, the information that's included, the scope of the information, and where the information comes from. Who tells you what to do? In phase 2, what influences the individual's situational awareness and risk perception? Phase 3, how do we select a response? Well, for instance, the presence of smoke does not necessarily preclude the use of a route. An individual may assess the presence of smoke differently given their proximity to an accident and their experience. Our commitment to a particular activity may cause us to not necessarily want to stop one activity and take up another. So, for instance, if you're in an expensive restaurant and you're halfway through your dinner, maybe you'll be slightly less reluctant to go outside into the freezing cold snow than you might otherwise be, because you're committed to your task at hand. If you're at work and you're working on a time-critical effort, maybe that will delay your movement to a door because you don't necessarily want to interrupt what you're doing and get in trouble with the boss, and so on. What factors influence the actions that we select? Well, for instance, we have different abilities. We move at different speeds. Some have more or fewer impairments, and so on. Critical, actually, to this decision-making process is that people will seek information. We are information hungry. So we don't necessarily hear an alarm bell, go to the door, or smell smoke, run in the other direction. You typically have to gather more information in order to define the situation and then respond. Also, and it is well documented, people move towards the familiar, be that other people, be it exits, be it routes, but there is a tendency to go with the tried and tested, to go with what you know. And this has an enormous impact on the way people use evacuation routes and indeed many of the actions that they choose in terms of finding relatives, finding possessions, and so on. And finally, what factors influence the overall decision-making process? So typically, even when we're responding to an incident, we have a goal. The goal is to get to a place of safety, or to make sure that people that we're with get to a place of safety. Those are goals. That's a rational process. Our pre-incident experiences influence who we are and how we behave. So we don't just become a different person because of the incident itself. Evacuation is a social process. We don't evacuate in a vacuum. Typically, certainly if you're not isolated, you are subject to the presence of others. Their identity and their actions can influence what you do. And as I've mentioned, your role before the incident will influence your performance during an incident. So what are we going to do with this information? The papers that we're producing address two things. What does the conceptual model look like that would be able to address these factors? What would you need to include? What structures? And then, given that that doesn't really exist in an implemented form, how might an engineer address some of those factors? So basically what all this is showing us is if you wanted to represent those factors, those statements that I mentioned, you'd have to represent the external cues that prompt the process. These cues would have to be perceived, attended to, understood, and determine whether they're credible, so that they can be personalised to the individual involved. Given that, the individual would have to interrogate the situation, understand what's going on, what's their situational awareness. So to do that, they'd have to work out, what's the nature of the event? What are the rules that are governing where I am now? And who else is present? And what is my relationship with them? Now, none of these are trivial, but in order to represent some of the statements I've mentioned, you'd have to at least to some degree have these structures in place. Given that's the case, okay, you've made an assessment of the situation, how much risk am I subject to? And then what options are open to me in terms of a response? Now, this is a significant, implementing and developing this in a way that could be used is an enormous task. But this is just a simple outline, if you like, a framework that might initiate that process. Now, as Enrico mentioned earlier, you can sort of boil down the key components of an evacuation into these 5 elements. The time it takes to respond, the speed that people travel, the flow conditions that are present, the routes that are available and the routes that are used. And the reason these were chosen is pretty much if you're going to use an evacuation model, they have to some degree, be able to address these in order to predict, quantify an outcome. So what we did was then go through each of the behavioural statements and say, well, which of the 5 categories could it possibly affect? Which of the what would the engineer need to look at? And in many cases, there may not be hard data available that says we know definitively the extent to which this affects that element. But you might be able to have a direction. Say, okay, this makes pre-evacuation time slower, faster, travel speed slower, faster, and so on. And so it may enable you to do some parametric analysis based on varying some of these elements. And this is just an example that we've put in the paper. But I think actually, reading this again, I think the biggest value of these statements is that it may just act as a benchmark against which any model description or any piece of engineering work can be compared. You can say, okay, I've addressed these elements, couldn't address the others because there was no data available. Couldn't address this because the theory didn't hold up or it wasn't relevant to my scenario. But at least you could then say, okay, you'd be more transparent about the process. This is what we know, this is what we agree with, this is what we've excluded. Why does it matter? Well, let's assume for a moment that there are 2 competing, if you like, approaches. There's a process-driven approach to human behaviour and a panic approach. One says, okay, if we indicate to members of the public that there's an incident, they will act simultaneously, they potentially might overload an exit, it'll be competitive, it'll be a stampede involved, and people will be directly affected by the very nature of the response, and basically the incident will need to be controlled. All you can do is corral people. And on the flip side is a process by which people internalise information, whether they understand it, whether they deem it credible, whether they think that it's actionable, personal to them, and whether they can take an action on it. So one basically is almost like a stimulus response approach, and one is a process by which somebody makes a decision. Why does this matter? Well, if you're designing an alarm on this or a procedure using that alarm, you're going to be reluctant both to set the alarm off and not really care about what information you put in the alarm because people don't make use of it anyway. That's the panic model. If you actually take the other approach, this actually then determines not just the fact as to when you use the alarm, but the design of the alarm itself, the design of the procedure. So the underlying astrological social sciences approach that people tend to put to one side has a direct impact both on the way that some of these models are produced and the outcome and the procedures that are eventually implemented. The assumptions that we make directly influence the engineering practice and the procedure outcome. So to summarise, what we tried to do was to compile a set of behavioural statements that were currently used in practice and in the research that's available. And we found that this set was both partial and incomplete. The reason we make that statement is because if you look in adjacent areas, there are much more rich, well-developed theories available. But it's extremely important to understand evacuee response in developing our conceptual models because, as I said, it provides both an instrument to inform the development of the tools available, the development of the tools employed, and the development of the scenarios that we're interested in. In addition, it allows us to benchmark all of this and say, this is what we're including of this is the subset that we're representing in our analysis. We're not excluding these other things because either they're not relevant or we don't trust the data that's available to represent them. Or indeed, we don't want to get involved in the parametric analysis that may be available. This isn't just art for art's sake. As I demonstrated, this has a direct effect on the procedures that we employ, which then govern the success or failure of an evacuation in a particular environment. Hopefully, this is the initiation of a discussion that will help produce a more informed and evidence-based approach to egress analysis and eventually to a more transparent design procedure. Okay, thanks.
Thank you, Steve. Do we have any questions for the speaker? Okay, one moment.
Hi, Steve. This is very interesting presentation. One question, how do you think we can link this parametric analysis that you're describing with selecting a model for use? This can be interesting for...
Well, I mean, if you were going to use a model for a particular environment and that environment was, you needed to look at many of these statements for that environment, and you would choose a model that could hopefully cope with some of these statements.
Looking at the table, it links totally to what I was discussing.
Yeah.
What I was discussing for validation. It's the
Yeah,
same.
I mean, it could link directly to that. But, and stepping back, I mean, with a competent user, you could represent nearly all of these statements if you break them down into the 5 core elements of pre-evacuation time, travel speed, and so on. So many of these more, how can I put it, qualitative statements can still be turned into, okay, it has this type of effect. The judgment is then, how big is that effect? Now, you can go to some of the data that's available. Not all of those categories are supported by data. But you can at least make a transparent effort in representing some of these issues. Now, it may be that that sort of flexible analysis is used to generate a few scenarios that the user then completely drives and says, okay, I want the people are going to behave like this. These are the numbers I'm going to use. But it may allow the user to investigate different scenarios that then produces a more robust response, I think.
Thank you.
So I think these last 2 presentations have been great. As a practitioner, I think I'm fully aware of all the issues you're talking about. And I see a lot of this coming from research like yourselves, which is great. What do you think is going to need to change? Who's going to need to instigate the change? Because I can't be sitting there looking at everything that you've done.
Yep.
I essentially need to come up with that number at the beginning. I just need a number to put in. Where do you think the changes are going to come such that it's more readily available for us?
Well, you're right in the sense that it can't be your responsibility as a practitioner to do this but you should be involved in the conversation. So in fact, the last thing you want is an external third party saying this. You don't want another set of regulations, but what you want is actionable guidance that says this is the stuff that you should be using, or this is the core of like the subject matter that you can address. Now, some of this is in hand in the sense that in the future evolutions of the SOP handbook, for instance, there's going to be a chapter on data that you can plug in, but that's still only the raw data. That's not the nuanced action of how can I fit this to the egress scenarios that I'm looking at. I think that, and Enrico alluded to it, that there has to be a movement towards some core elements of what needs to be in a model and what needs to be in a modeler, just as much as what needs to be in the third party that's assessing the results produced. And I think the process lacks more than any of the individual components, actually. I think, as you say, most practitioners are fully aware of the subject matter that's available and what's actually slightly more vague, and where the problems are in terms of empirically supporting some of those statements. What's less well defined is the structure that takes you from defining the problem to interpreting the results. And as I say, I think that's a bigger issue that needs discussion between international organisations, individual practitioners, and researchers in the field. So yeah, I totally agree.
Okay, thank you very much, Steve.